Now, both the size function as well as the size of operator return a value of type size t. What is this? Well, t here is short for type. So size t is a type or a data type defined in the standard library that is used for representing the size of objects. It's guaranteed to be large enough to contain the size of the largest object the system can handle. Let me show you what I mean. So let's print the size of int followed by an endl, and then we're going to print the size of size t. So size t is a data type just like integer, but it can hold larger values. Take a look. So on this machine, an integer takes 4 bytes, but a size t value takes 8 bytes. So it takes more memory and it can store larger values. This is equivalent to the long type. So if we change int to long, you can see that both these types take 8 bytes of memory. The difference is that long values are signed by default, so they can be negative or positive, but size t values are always positive, so they can store larger values. Let me show you what I mean. So earlier, we talked about the numeric limits class. So numeric limits, this is defined in the standard library. So if you haven't included the std namespace, you have to qualify this with std double colons, okay? Now, this is a generic class, so we have to type angle brackets, and then we specify a type, like long. Then we type double colons, and here we can access the functions in this class. So we're going to look at the minimum and maximum value that we can store using the long type. Then after that, we're going to do the same, but look at the minimum and maximum values we can store using size t. Size t, okay? We don't need the last line. Now take a look. So this is the range of values we can store using the long type. As you can see, the values can be negative or positive. But the values we can store with the size t type start from 0 up to this number, which is larger than the values we can store using the long type. So more accurately, size t is equivalent to unsigned long. But of course, this is dependent on the compiler. If you have a 32-bit compiler, size t is the same as unsigned int. Otherwise, if you have a 64-bit compiler, size t is the same as unsigned long. So there's nothing magical about it. It's just a data type for representing the sizes. And as you saw, this type is guaranteed to be large enough to contain the size of the largest object the system can handle.